In this video, we're going to solve a few linear equations. Let's start with this one. -4 equals 32 minus 9y. I know that I'm looking at the equation because I can see equal sign. Now, what it means to solve an equation? It means that we need to find the value of y such that when we plug that into the equation, or in other words, replace y with that number, we get a true statement, which is the left-hand side equals the right-hand side. How do we find that number? So a good approach to solving a linear equation is to think that you need to isolate the variable, in this case y. So goal is to isolate y. Now, when we say that we want to isolate y or get it by itself, it doesn't matter on which side it's going to be alone, on the left side or on the right side. We can see that in this equation, variable y is already on the right-hand side. So we can keep it there. It's totally fine to keep it there and get it by itself on the right-hand side. So to get y by itself, we need to get rid of numbers that are next to it. So there's 32 and there's also -9. In which order do we remove numbers from the right-hand side? Well, keep this in mind. The number that's right in front of the variable, which we call the coefficient, right? -9 is the coefficient of y. That number we're going to leave for the very end. We're going to take care of that number at the very end. Well, since there's nothing else there besides 32, it means that we're going to start with 32. So let's think how we can remove 32. Well, if I have positive 32 here, then for that number to disappear or become 0, I need to subtract it, right? Because if I have 32 minus 32, that becomes 0 and it disappears. Now, when we solve equation, we have to also remember that we want to keep it balanced. So the left-hand side should always be balanced with the right-hand side. And if we need to take away 32 from the right-hand side, then we also have to do the same thing on the left-hand side. So we're going to need to subtract 32 on the left-hand side. Now, the right-hand side, we know 32 goes away, but what's going to be the left-hand side? It's -4 minus 32. So following the rules for combining signed numbers, we know it's going to be -36 equals, and then on the right-hand side, we only have -9y that's left. Okay? So next step is to remove -9, right? To get rid of -9. It's a coefficient, so we always have to remember that between the coefficient and the variable, there isn't a multiplication operation. So here we have multiplication. And one way to think about it is that if we want to remove that coefficient, get rid of -9, we want to undo the existing operation. If the existing operation is multiplication, then I will need to undo multiplication by dividing. So I will need to divide by -9. So while we use opposite signs when we add or subtract to cancel numbers, when we divide, we want to divide by the number with the same sign, because think what happens if I divide by +9. What is -9 divided by +9? Well, it's going to be -1, right? -y, in other words. And I don't want -y. I want just y. I want everything to go. Signs, numbers, and signs. That's why I want to divide by number with the same sign, -9, because -9 divided by -9, it's technically 1, but I don't have to write the coefficient 1, right? So that goes away. But to keep my equation balanced, I'm going to divide on the left-hand side as well. So when I'm dividing the left-hand side, I'm getting -36 divided by -9. Negative divided by negative is positive. +4. +4, and the right-hand side is just y. And then once I get by variable by itself, once I isolate y in this case, then what it equals to on the other side, well, that's supposed to be a solution. Let's check. It's always a good idea to check, because what if we miscalculated something? So I'm going to check. And 4 is going to be a solution to this equation if when I substitute y with 4, I'll get true statement. Let's try. So I'm copying everything down except y. I'm replacing with 4. Now again, it's negative 9 times y. So here I'll have negative 9 times 4. And the question is that a true statement? Is the left-hand side equals the right-hand side? Let's see. Then the left-hand side is 4, negative 4. On the right-hand side, I need to follow the order of operations to simplify that. First, I need to multiply. Negative 9 times 4. That's negative 36, right? So it's 32 minus 36. Is that true? And then 32 minus 36, yeah, that's negative 4. So negative 4 equals negative 4. True. It's a true statement, so it means that y equals 4 is the solution. So solution. So that's how you solve the basic linear equation. Let's look at one more example. So next we're going to solve the following equation. Negative 4y plus 15 equals negative 9y minus 20. When we look at this equation, how is it different from the first one? Well, hopefully, besides, of course, it has different numbers. But hopefully you can notice that in this equation we have variables on both sides. I have y on the left-hand side and I have y on the right-hand side. Right? So notice how we have variables on both sides. So when it happens, when you have variables on both sides, and by the way, our goal is still the same, to get y by itself, to isolate y. But if you have variables on different sides of the equation, then the first step, step 1, will be to collect all variables on one side. Collect all variables on one side. So you basically make up your mind, choose the side and go for it. So let's say we're going to collect variables on the left-hand side. I want y to end up here on the left-hand side. Well, if that's my goal, if that's what I want, that means that I don't want to see y on the right-hand side. So I don't want to have negative 9y on the right-hand side because of that. Well, then I have to get rid of it. How do I get rid of negative 9y? By adding its opposite, right? So if I have negative 9y and I add 9y and combine like terms, well, I'll get 0. They're opposites, so they cancel each other. So that will go away. Now, if I only do it on one side, my equation becomes unbalanced. I want to keep the balance. So if I decide to add 9y to the right, to the right side, I have to do the same thing on the left-hand side. And that means that over here, I will add 9y as well. And notice that I'm writing it underneath negative 4y because those two are like terms. There's no point of writing it here because I would not be able to add 15 and 9y, right? So I'm putting this here so that I can combine like terms. Let's see what that's going to be equal to. So negative 4y plus 9y. Remember, when we combine like terms, we just need to do it in terms of coefficients. So negative 4 plus 9, it's positive 5. So that'll get positive 5y. That's the result of combining like terms here, and then I bring down everything else. Now I have to carefully rewrite everything else I have. 15 I bring down equals sign. Now that's gone. That goes away, and I still have negative 20. So that's how you collect variables on one side. After you completed that step, then now we can really think about our ultimate goal is that's isolate y, get y by itself from there. So to get y by itself means to get rid of the numbers that are next to it. And remember that the number that we call coefficient that's right next to the variable we're going to take care of at the end. So that means that first we'll remove 15. Well, if it's plus 15, positive 15, I need to subtract it. Subtract minus 15. 15 minus 15, that's 0, so that goes away. But then to keep equation balanced, I'm doing same thing on the right-hand side. Let's see what we'll end up with. So 5y, that's the left-hand side, and negative 20 minus 15, that's going to be negative 35. Negative 35. Okay, we're almost there, right? The last number to get rid of is 5, the coefficient. 5y means it's 5 times y. left. So to remove the coefficient, we're going to do reverse operation. So we're going to divide. Divide by 5 on the left, divide by 5 on the right. So here, y equals negative 35 divided by 5, that's negative 7. So that's going to be a solution to this equation. To check, you would take negative 7 and you would plug that into each y, right here and right here. And the last equation that we're going to solve here is the following. 5 minus 8x minus 24 equals 7x plus 11 minus 5x. Now, how is this equation different from the previous one? In this case, we also have variables on both sides. I can see x on the left, I can see x on the right, but what else is different? Well, maybe you can notice that this time we have on one side, on the right hand side specifically, we have more than one occurrence of x. We have 7x and we also have negative 5x here, or minus 5x, right? That's something new. We haven't seen that yet. So when that happens, when you have same terms, same kind of terms on either side of the equation, then we always start by combining like terms. So that's the very first step in this case. So step 1, combine like terms on both sides. I like to say clean up both sides as much as you can before doing anything else. Let's actually look at the left hand side. Do we have anything to combine here? Yeah, looks like we actually have numbers to combine. So we can combine 5 and negative 24. Combine. And on the right hand side we can combine 7x and 5x. Combine. Okay, so what is 5 minus 24? That's negative 19, I think. Negative 19, right? And then I bring down everything else. So negative 8x has to be brought down. Minus 8x. That's the left side. On the right hand side, 7x minus 5x. 7 minus 5, that's 2, so it's 2x. 2x, and I bring down 11, plus 11. So that's how my equation looks like after I combine like terms. Now, when you confirm that nothing else you can do on each side, nothing else to combine, nothing else to simplify, well, then you're gonna collect all variables on one side. Collect all variables on one side. On one side. You get to choose the side. It doesn't matter if it's left side or right side, eventually you're going to get to the same answer. But as I said before, sometimes people or students like to choose specific side because it will give them positive coefficient of x. And if you can think a little bit ahead like that, that's fine. Go ahead and pick side with that thing in mind. But as I said, it doesn't really matter, so you're safe choosing any side. Now here I am thinking a little bit ahead, and I can see that if I collect variables on the right hand side, I will end up with a positive coefficient of x. So that's why I'm making this decision right now, but left side would be totally fine as well. So one more time, we're collecting variables on the right hand side. So over here, it means that I don't want to see variables on the left hand side. I don't want to have negative 8x on the left. I need to get rid of it. How do I get rid of negative 8x? It will be cancelled if I add 8x, right? Because negative 8x plus 8x, they're opposites, so they cancel each other out. But if I add 8x on the left, I have to add 8x on the right hand side as well to keep equation balanced. So let me rewrite what I have now. On the left I have negative 19, right? Bring that down, that's gone. Equals, now when I combine like terms 2x and 8x, I'll get 10x, and then I bring down plus 11. Okay, so now I collected all variables on one side, so I only have one place where I have x. And after that, you can say that step 3, that you really need to isolate the variable. Isolate the variable. In other words, remove all numbers that are next to it. So 10, since it's a coefficient, is going to be the last number to go. So we'll start with plus 11. If it's plus 11, we need to subtract 11, so it disappears, right? If I subtract 11 on the right, I have to subtract 11 on the left. Okay, so from the right-hand side, it goes away, but on the left, it's negative 19 minus 11. That's negative 30. And on the right, I only have 10x left. Okay, and finally, to get x by itself, we're going to get rid of this coefficient. It's 10 times x. So to undo that multiplication, I will divide by 10. 10 divided by 10, that creates coefficient 1 that I don't need to write. So it's just x basically, right? So that cancels. 10. But I can't just do it on one side. I have to do it on both sides. So divide by 10 on the left side as well. Finally, negative 30 divided by 10, that's negative 3. And the right-hand side is x. So negative 3 equals x. It's same thing as x equals negative 3. Well, if two things are equal, then it doesn't matter where do I start, right? On which side I start. Negative 3 equals x. It's same as x equals negative 3. So that's going to be the solution to this equation. If you wanted to check that solution, you would have to take negative 3 and replace every x in the original equation by negative 3. You would put negative 3 here, over here, and right here, and then you would simplify everything as much as you can, hoping that the left-hand side turns to be the same number as the right-hand side. That's how you will prove or show that negative 3 is the solution. So these are the steps for solving equation like that. Combining all terms on each side. Don't move them around yet, so don't move them from side to side, just combine them together. Then you start moving things around. Then you would collect variables on one side, right? You collect variables on one side, and then you will get rid of the numbers that are surrounding x so that x gets by itself. And that's how you will obtain solution.